Hey everyone, I have some quick directions for you on how to do this Skittles lab. So hopefully this helps clarify what you're supposed to do and what it should look like. Before we get into the lab, just one slide just to kind of clarify what we've learned so far. So the first real topic we studied was differential rate laws. And what that did is it looked at instantaneous rates, really actually the initial rate of a reaction. So one snapshot in a certain time. So usually it's at the beginning. So like right when t equals 0, right when it starts, that's what we're looking at. And we needed the experimental data to determine the reaction order. So we saw different experiments where one thing might change and the other is constant, and then the other thing was constant, and then the first thing changed. So we used that to figure out the rate order for the reaction. Integrated rate laws is that we're taking one reaction, not multiple experiments, one reaction over time. So I'm looking at the concentration of one reactant over a period of time, and then what we're going to do is we're going to graph that. We're going to take what is the concentration over that period of time, and then we can do the natural log over the period of time and 1 over the concentration over a period of time, and that will help us to determine the order for that one reactant for the reaction based off whatever graph is most linear. So they're both ways we can write rate laws. How are you supposed to choose? Should I do the differential? Rate equals k times, so that's the one that looks like this. Rate equals k times a to whatever power we get. Or should I do something like the concentration of A at a certain time is equal to negative k times time plus the concentration of A at 0, and this could also be natural log, or it could be 1 over, that depends on the order, okay? So how do you choose, I guess, is my question, if I should write it like this or if I should write the funky looking formula. Well, that's really what information is given. In this lab, you're going to be looking at the amount of something over time, so you're probably going to use the integrated rate law. Can you also write it in this format? Absolutely, but you only want to do that if it's useful for you. So if there's any question about at what time does this happen, or at this time, what's the concentration, you're going to be using the format of the integrated rate law. Hopefully that helps, but just so you know, both are acceptable. It's just a matter of which one's more useful for you. Okay, so this Skittles lab, and maybe we should do both, because Skittles is an air quote because you may or may not be using Skittles. Lab is in air quotes because this is more of an activity. So you're not going to do this in your lab notebook. You can just do it on the lab sheet or on a separate sheet of paper. But what you're going to do is we have this simple reaction, A makes B. A is the reactant, B is the products, and we're going to use data to just start to get to know and work with the integrated rate laws. So we're going to figure out how the concentration of A, the concentration of our reactant, changes over time. And so then what we'll do is we'll fill in a data table. Once we know the concentration of A over time, we can take the natural log of A and we can take 1 over A, and we are going to graph by hand today, going old school on you, 3 separate graphs using that information, and then you'll be able to complete calculations and analysis questions based off the graphs. Okay, so some of you are in the classroom today, so you're going to use Skittles. Some of you are not in the classroom, so you are going to use whatever you have 100 of in your house. My favorite card game is called Skip-Bo, and there actually is a really big deck for Skip-Bo. Here's all of it. And so I counted out 100 Skip-Bo cards. Okay, Phoebe Buffet is bummed because she wanted me to do 100 pieces of her dog food, but I wanted to use the Skip-Bo cards. I'm sure there's something you can find. Maybe there's pasta in your cabinet that you could use. Maybe there's peanuts or really pieces of rice. I don't care. Anything you can find 100 of. Go find 100 pieces of something and you'll use that. So here's the idea, and you can pause the video and kind of read it yourself. So actually do that, please. Pause. Great, hopefully you read that background information. So here's the idea. You have 100 of something, and you're gonna represent going from A, the 100 reactants, to form B, the products, and you're gonna pass from student A to student B. If you're in the classroom, make sure you're sitting on opposite sides of the table, so face each other, but if our table's like this, one kid here, instead of side by side. And so you can face each other, and one student will start with A and they will pass to B, so that's reactants is A to B products. If you are at home, find someone that you can pass to. If you're in quarantine and can't be around anyone, maybe a pet, Phoebe! Maybe a pet you could pass to. I'm happy to sit on this video for a little bit and smile, and you can pass to me. A teddy bear, a pillow, the couch, I don't care. Find something to pass to. You are the reactants, you'll pass to the products. Come on, Phoebes. What you're gonna do is you will pass 10% of what you have in your stack of A per second. And each time you pass, that represents a second. Okay, and then we'll fill out this table. Here is where you will make the graph. So you'll graph the concentration of A, and it also gives you directions for B in a separate color. Then you'll do the natural log versus time. You'll graph 1 over A versus time. And these questions, if you could please answer these and these on a separate sheet of paper. So you'll turn in your graphs on this paper, but separate sheet of paper for the analysis questions and the calculations. That way you have plenty of room. I purposefully did not give you enough room to show your work on here to force you to do it on a separate sheet of paper. Okay, so I have my assistant. I'm partner A, Phoebe is partner B, stay. So I am starting with 100 skip bow cards. And so that means Phoebe has 0. So you can see in the chart, I have 100, Phoebe has 0. And then I took the natural log of A. So natural log of 100, 4.605. No, sit. Stay. And then I took 1 over A to fill this out. Okay, so what I'm going to do is I'm going to take 10% away. So if I have 100, 10% is 10 cards. And I'm going to give 10 cards to Phoebe Buffet. Phoebes. On video. Don't do that now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, pay attention. Okay, so Phoebe now has 10 cards, and if I started, hey, focus. If I started with Phoebes. If I started with 100 cards and I gave 10 to Phoebe, that means I have 90, so I can take the natural log of 90 and 1 over 90. Now I need to take 10% again. So 10% of 90 is 9 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I give those to Phoebe, now she has 19, and I'm left with 81. 10% of 81 is 8.1. So I need to give up 81 minus 8.1. Well, that would give me 72.9 cards. We're going to round to the nearest. Hey, come on. We're going to round to the nearest whole number. So if I need to be at 72.9, that's 73. So I really need to be giving Phoebe 8 cards. 1, 2, 3, 4, 5, 6, 7, 8. So that'll give me a whole number, 73 total, and her 27. Okay, so you'll round to the nearest whole number, and you're going to do this for 15 seconds, so 15 passes, and you'll have numbers here, and then you'll take the natural log of this first column A, and then 1 over A, and fill out your chart. Once you've had your concentrations, you will graph concentration of A versus time, and I believe it has you do concentration of B as well, just so you can see the comparison. We'll take we'll take the natural log of concentration of A versus time, and 1 over the concentration of A versus time. So based off your 3 graphs, you should then be able to answer the analysis questions and the calculations. Feel free to use your integrated rate law video notes if you need the help, and reach out via email if you're not in person, or you can even jump on our class Zoom call, because I'll be on Zoom this week as well. Whatever you need to help you out with this lab. Again, do the analysis on a separate sheet of paper. I hope you have fun with it, and I am here, so if you need to pause the video right now so you have someone to pass to. Are you passing them? You can pass the cards to me. Okay, good luck, everybody. Let me know if you need any help.